Hey guys, I know some of you were struggling with the area of, or the surface area of pyramids that we've done on Imagine Math. I know that we didn't really get a chance to learn it in class this year, but I wanted to make sure that you had an opportunity to get a little bit of support on this lesson. Um, so I'm going to go through the guided learning portion with you, these 3 questions. Before we get started though, please go get a notebook and a pencil because I would like you to write notes down on what you're learning through this. That way you can use them in the in the practice without the guided learning and also for the post quiz. And it's an opportunity for you to ask good questions based on the notes that you took. Okay? So the first thing that we have to do is to read the question. A rectangular square pyramid has a base edge B, a height H, and a slant height L. Okay? 3 expressions give the surface area, A, of this pyramid. Which expression does not? So there are obviously surface areas is the area of the surface. Now, if you're not understanding what I mean by that, go ahead and click on the highlighted portion and we're looking at the reference book. Okay, it says that the total area of a surface of a solid figure. The surface area is the sum of the areas of the surfaces of the shape. So if I were to wrap a gift in a pyramid shape, I would be wrapping the outside of the gift, and that would be considered the surface area. Okay, so when I'm looking at the surface area, it says square pyramid. That means that the bottom of this shape is a square. Okay, so that means I am doing B, because they said that was the base edge, times B to find the base. And remember, B times B is the same as B squared. Okay, so go ahead and write that down. We're looking at the base, write the word base, and then B times B equals B squared. Because remember, with a square, both the length and width of the shape are the same. So that's B squared, base squared, or side squared as we talked about when we were doing area of squares. Now, moving forward from that, we are talking about these outer edges, okay? These outer sides. This triangle, the triangle over here, and the triangle in the back. Okay, and it's kind of hard to see it this way, which is why I would suggest looking at it as a net. And since I don't really have that available to me right now, I'm going to look at the math help and see if they turned it into a net and see if they also give us a little bit more guidance.
Examine all its surfaces. You can unfold the pyramid and flatten its sides to examine all its surfaces. Point O can go with any or all of the lateral triangles. Click the net to investigate its surfaces.
Okay, so if we are separating them out into its surfaces, you can see that triangle there, that base times base, but we also have this L, this length. So we have base times L giving us the area of the triangle. And since each of these triangles are equivalent, because the base is equivalent and they all come to a point at the middle, we can know that each of these rectangles are the same. Okay, so base times L, B times L, okay? But I don't have just one of those, I have 4 of those, and they're the same. So I can do B times L times 4, except it's a triangle, right? So what am I really doing? B times L, or base times height, divided by 2 times 1, 2, 3, 4, okay? So going back to our page here, I'm going to have to find 4 triangles. So this 4 here seems to make sense because I have 4 triangles. The area of the triangle is times 4. The area of the square is also part of it. So this is a correct expression. So that's not my answer because it says not. Okay. The second one has that b squared we talked about, and then it says times 4, but it's important to note that we've got 1/2 times base times length, okay, or b times l. So this is 1/2 times base times height of the triangle, which is how we find the area of a triangle, times the 4 triangles times the square. Okay, so that's also correct. Then we have the area of the square plus the sum of the areas of all the triangles, right? So that's all the triangles. There are 4 triangles, okay, and the sum of the areas. So all of the areas added together. So that would also be correct. And nowhere in our work did we see anything about 1/3. So this has to be wrong. Ta-da! We got it correct. Okay, the next one is, which change will double the lateral surface of the rectangular regular triangular pyramid with a base length B, height H, and slant height L? Okay, so it's asking which change will double the lateral surface area. Okay, well, what's lateral surface area? The lateral surface area of a solid figure is the total surface area of the faces of the figure that are not the bases. So in this case, if I'm talking about a triangle, I'm talking about the sides of the triangle and not the bottom of the triangle. Okay, so in this particular example, we're going to have, if it's a regular triangular prism, remember a triangle has 3 sides. So we're going to have 3 sides instead of the 4 sides we had in the last example. Okay, so if I want to double the lateral surface area, I need to somehow double those numbers. Okay, so I'm going to go to Math Help to see if that can help me. Oops.
Congruent sides that are the original pyramid has 3 congruent sides that are triangles. The area of one triangle is 1/2 times b times L. The area of 3 triangles is 3 times 1/2 times b times L. You can double the lateral surface area of the pyramid by doubling the areas of all 3 triangles.
So if I'm doubling the area of all 3 triangles, I've got to figure out how to make the B bigger or the L bigger by doubling. Well, if I'm doubling, then I'm going to be multiplying by 2. Only one of these, though. You don't need to multiply both by 2. You only need to multiply one by 2. Now, if that was confusing, we can also go to the second help. Oops.
Times b times L.
Sorry.
Here is a lateral side of the pyramid. N equals 1/2 times b times L. One way to double the area of this triangle is to double the slant height, L, while keeping the base, B, the same. N equals 1/2 times b times 2L, which is the same as 2 times 1/2 times b times L. Find another way to double the area of this triangle.
Okay, so we are multiplying by the L to make it taller, or we can multiply by the base to make it wider. But remember, we're multiplying one of them times 2. So let's see which one of these talks about that. Well, this says double the height. Well, the height didn't really matter, did it? We didn't talk about the height. We talked about the base and the slant length, okay? Because that's the height of the surface area, is the slant height, okay? So could we just double the slant height and the height of the pyramid? Not really. Actually, the height of the pyramid is probably going to go down because the slant height goes up. So that's probably not it. Could we double each side B of the base of the triangle while keeping the slant height the same? We could, but that wasn't really what it talked about in the video. It said to double the slant height while keeping the height H of the perimeter the same, or the pyramid the same. So it's this one or this one. Let's see. Aha! Because we doubled one of the sides and it didn't talk about that height. So we're going to move forward. Okay, now this is the third one. It says a picture shows the net of the pyramid. 3 statements about this pyramid are true. Which statement is not true? Okay, so remember we're looking at a regular square pyramid. So this is 5 and this is 5. That's how we know this is a square, because the base of 2 triangles is 5 and it's a 4-sided shape. Okay, so 5 times 5 is 25. So what is the area of the base of the triangular pyramid? 25. So that has to be right. The lateral area of the pyramid is 4 times 1/2 times 5 times 12. Well, if the lateral height is 12 and the base is 5, okay, that would mean that to find the area of this triangle, we would be doing 5 times 12 times 1/2. And there's 4 of them. 1, 2, 3, 4. And if you remember correctly, the lateral area is the area of all the sides and not the base. So that, again, is going to be true. The slant height of the pyramid is 12. Remember, this is the height of the triangle, the slant height of it. When I put these four together, that's not going to be the height going directly up from the center of the the square pyramid. It's going to be something different. So that is correct because the lateral height is the side length height. Okay, so that's still true. And then the total surface area is 5 times 5 plus 1/2 times 5 times 12. Remember, this is one side length, okay? But I have 1, 2, 3, 4 surface areas that I have to add, not just one. So that's got to be wrong. And remember, going back to the statement, it says which one is not true. This has to be the right answer. Okay, so I hope that was helpful. If you have any questions, please let me know. And I hope to see you be successful. Have a great day.